Kearney Trecker here at VintageMachinery.org. So last week, if you watch my odds and ends video, you probably already got a little heads up of what this project's about. But last week when I was in the shop, I decided that it was time to do some maintenance on my Kearney Trecker 2H horizontal milling machine. Something that's been aggravating me for quite some time now has been the rapid traverse. There's a slip clutch in the machine that on the rapid traverse, where if you were to hit something or come into some resistance, instead of it just keep on plowing through until it breaks something, there's a slip clutch in there that will actually slip to keep that from happening. And on my machine, this slip clutch was just slipping all the time. It was just about any time you engaged it in any of the three axes, even when everything's loose, I could crank it by hand, no problem at all, no tension, no resistance. The feeds worked just fine, but when you put it in rapid traverse, it was just you just hear this noise of it clicking. And I've been kind of living with it for a while, and I got tired of it and said, no, it's time to fix it. So I started tearing into the mill and basically had to take all these parts off, plus a whole bunch of other stuff. And today we're going to put it all back together. So I'm going to zoom you in on this little slip clutch and kind of let you see what all is involved with it, and tell you about some of the problems that we found and what we're going to do to hopefully resolve those problems. So first off, let's kind of give you a little orientation of what we're dealing with here. So this pulley right here is basically the main drive. There's belts that go down to the motor, and there's two bevel gears on this, and these two bevel gears, depending on one of them is going to turn all the time, so it's directly keyed to this pulley. So anytime the motor's on, it's constantly turning. The other one on here only turns when the clutch is engaged. It basically engages the spindle on the machine. So and the reason there's two gears here is one is for the rapid traverse, which can be used anytime the machine is on. So anytime the machine is turning, this is going to be turning, and it will basically allow the rapid traverse to run. The second one powers the feed on the machine, and it only is engaged when the spindle is engaged. So just like anytime you would only want the table to be moving, be feeding when the spindle is turned on. And this whole assembly goes through this big block that's laying down flat. Basically, this spindle here is going to come up, and these two gears here will engage these two gears, and these two gears here in turn, basically what they're doing is they're transferring the motion from horizontal to vertical. So it'll be horizontal here, and then these two shafts are going to go down, and will basically 90 degrees down, and then it feeds into another set of gears, actually these gears here, that then go into the knee of the mill that actually powers everything. So again, one of these gears here is going to turn one of these spindles, and the other one is going to turn the other. One of them is always on, which is the rapid traverse. The other one is only on when the mill is engaged. So I know this is kind of complicated, and maybe you'll make a little more sense when we start putting it back together. But this is the slip clutch mechanism, and it actually sits down right here. And this gear here is going to mesh with this gear. And again, the idea is that if this thing gets in a bind, that this gear will just slip. But it's going to have enough torque in it, or it's going to be preloaded enough that under normal operating conditions, it's going to turn it just fine. But if it gets in a bind, it will slip. So let's look and see how that works. So let's look at these parts of the slip clutch all taken apart. So first off, you got this piece here, and basically a plate that's got a bunch of little holes in the bottom. They're actually radiused to a 5/16 inch radius, and there's a little ball bearing that fits down in each one of these little holes. And a couple of comments here. When I took this apart, there's a wear mark in here where these balls have been slipping, and that's what they're designed to do. They're under spring pressure, and basically The spring pressure pushing down on this will allow it to hold in those detents, but when the pressure gets too much, there's a spring above this. That spring will push up and it will slide around. Well, over time, we've got a little wear mark that's gone from one groove to the other, and you know, that really shouldn't be in there. It's not that bad. I was real concerned about it at first, but after looking at it a little bit closer and studying it, I don't think that's the big issue. And I will say that we found a couple of issues as we were taking this thing apart. Now, it was very obvious to me as I was taking it apart that someone had been into this machine before me, there, you know, you could see where, you know, screwdrivers had, you know, messed up screw heads and things like that, where they really weren't doing a very careful job, quite honestly. But when we got inside of this, I noticed that the springs that were in here, these are not the originals, these are replacements, but there were about 3 different kinds of springs that were in there. Some of them you could tell, quite obvious, were original to the machine. Some of them you could tell just were replacements. The replacement springs were not near as strong as the originals, which was one problem. And because it wasn't pushing enough pressure down on that ball bearing, and it wasn't basically giving you the amount of, it would require too little torque for this thing to slip. I also got doing some measuring, and I was measuring these ball bearings to see what size they were, and I was kind of surprised that it was an oddball measurement. It wasn't a nominal size. And you know, this machine that I'm working on, I think, was made in 1942, and you know, a USA machine made in 1942 really should not have any metric parts in it. And I knew from the catalog that these were supposed to be 5/16 of an inch based on the parts manual. And again, I measured them. That was the size didn't come out to a nominal size. I was using a pair of digital calipers, and I clicked the millimeter button, and lo and behold, they were 8 millimeter. The ball bearings were, which is about 20 thousandths of an inch larger than 5/16. So we had 2 issues going on. Number one, these balls were not properly seating down inside of these. They were a little bit large, so they were not going quite as deep into that hole. And second, we didn't have the proper tension on each of the ball bearings. So I took and actually purchased some brand new 5/16 inch ball bearings, which are here. I also took a 5/16 inch ball end mill, and I just kind of cleaned up each of these holes. So, you know, there was over time, particularly with those larger bearings that were in there, you could tell that you know, there was wear at the top of the hole. There wasn't any wear at the bottom of the hole. I didn't really make them any deeper, but I did go around them and just kind of peck them just a little bit, kind of clean them up, and hopefully get some good sharp edges all the way around that. And that might also help compensate a little bit for this little wear that's in here. So we're going to go ahead and put the ball bearings in and show you how the rest of this goes together. All right, the next part that goes on is the actual gear. And if you look, this gear has all these holes in here. There's 18 ball bearings in here. There's 18 holes drilled in here, and it gives enough clearance for those ball bearings. And what happens is that ball bearing is actually riding inside of these holes. So some people were asking me in some comments and stuff about how it tracks from one hole to the other. Well, the ball bearing never actually leaves this chamber. It's in there all the time. So this is what's guiding it around and keeping it in that circle. There is a little bronze bushing that's in here, and this is kind of tight going across the top. Once it gets on there, it drops right down. And this is the trickiest part of the whole thing, is getting this put in without knocking my ball bearings all over the place. All right, so now you can see this thing here turns around, and those ball bearings are captured inside of these holes. So let me, all right, that's down. The next part here are the springs, and again, using the springs that were original to the machine, and I could tell, you could tell just by the age of the spring, the quality of the spring. You could tell which ones were original. So I took measurements of those original springs as far as the diameter, the inside diameter, the gauge of the wire, and the length. And I was able to source some new springs that had that same specs, and actually was able to find them in the McMaster car catalog online, which worked out real well. This is just a little, I don't think this is actually a die spring here, but it's very similar to a die spring. I think each one of these springs, according to the catalog, gives about was it 16, 17 pounds of pressure pushing down on it. All right, so again, that's going to push that spring down. These springs will be compressed. You know, they're up a little bit higher right now, but they will be compressed and be under pressure. The next thing that goes on is this piece here, which is just simply a piece of clutch material. And on top of that will go this metal disc. And again, this is going to give some more friction. So again, you know, this top metal piece is going to be, it's keyed to this little stub axle, but this clutch plate will actually slide up underneath it. So as it's spinning, this is a clutch material, and it will hold it in place. All right, so the next challenge that we've got is we've got to be able to press all this back together. So I've taken the springs out temporarily here just to fit this on here. And as you can see, this little ring here is going to press down, compress all the rings, and there's a retaining ring that will slip up underneath this little groove. And again, what I've got to do is I've got to get it all pressed down, and I got to get this retaining ring in. Now we've got this little chamfer right around the edge of that, and if you look, the retaining ring fits right around that chamfer. So what I'm going to do is I'm going to go over on the lathe. I'm going to make a little tool to press this on, and what I will do is I will machine a hole just big enough to slide around this outside ring, and what it'll do is it'll sit on top of this. We'll take it on the press, and we'll press down on top of this retaining ring, and then that will then press everything down through here, and the pressure will actually, once the retaining ring gets down that groove, it should snap right back down into it. That's the plan. So I'm going to make a little fixture over on the lathe now to press all this back together. So we will start by just facing both sides of this, and we'll punch an 1 3/8" hole into one side that should slide right up over that arbor. Down deeper than the grooves, so we should be good. All right, let's reassemble this one more time. clutch pad goes on. Clutch disc goes on. The retaining ring will go on top of that. And with any luck, we can push that down with the press and it'll all snap in place. Let's see if we have any luck. All right, we're over here at the press now. See what happens. Let's see, I heard it click. Let's see if it snapped in. No. I don't think my ring is lined up just right. It's going to take a little trial and error. Alright, so it's down all the way. I've been around here with my light looking at it and I think it's in the groove, so I'm going to carefully relieve the tension on this. And see what happens. It's not springing back up, that's a good sign. Alright, we got the ring on there. That looks good. All right, guys, looks like the clutch pack is all back together again and ready to go back on the machine. So hopefully that will do the trick. So let's go ahead and get this reassembled back on the part it came off of and try to put this machine back together. All right, so this gear is going to fit right down on the spindle right here. There's a keyway in there, there's a Woodruff key. I pulled out the original Woodruff key and this thing is it's kind of chewed up. It's been in there a while. It's got some wear in it, so I went and got my assortment of Woodruff keys, and I've got a brand new Woodruff key we're going to put in here. And let's see if this will go right on. All right, we got this all put back together now. Looks good. Last thing we need to do is, as you can see, this gear here is pretty much, it's turning through here through this key, but in the case where it slips, this inner shaft will turn, whereas, or I guess this outer shaft will turn, but the inner shaft will just slip. So there's a clip that goes in here to just keep those two shafts together. And there we go. That's good. So this is all pretty much back together. So again, there's two gears that come out of the back off the main drive. This one here is turning the rapid traverse gearing. Anytime the machine's running, this shaft will be turning, whereas this gear here only turns when you engage the clutch on the machine. So two separate gear trains, and again, one's for rapid traverse and one is for the feed on the machine. One other thing I'll note, and I've already got it fixed now, but when I got in here, this gear here was actually flipped over upside down, which made it where it didn't align properly with the gears coming off of the main drive. This gear here was engaging the other gear, but only about 1/8 of an inch of these two gears were meshing. So I realized that was a problem, and in the process of putting this back together, I went ahead and flipped that over, so these gears should mesh up like they should now. So this is ready to go back on the mill machine. So let's get going. All right, guys, I'm working in real tight corners over here, so I'm not sure how well you guys are going to be able to see everything going back together. But I wanted to, before I put this in here, kind of show you where it goes. So that whole housing, I'm going to use a pointer here because there's just not room for you to get in here. The whole housing that I'm working on kind of bolts in right here. And this shaft through here will be where the main drive is on. It'll be belted up from down here. And then the gears will come in here, and this is where they will all mesh together. And then you'll have those two down rods that will come down through this mechanism here, and these gears then go into the knee. So basically, we're transferring power, you know, from going in this direction to going down and then going across. We're making two 90 degrees, making it go from horizontal, we're going 90 degrees down, and then we're going 90 degrees off of that again, perpendicular to this shaft. And that's basically the whole purpose of that whole gear train that we're working on. And again, these drive the two shafts here drive, one drives, the top one here drives the rapid traverse, the bottom one drives the feed going into the knee. All right, we got it started. So we got the gear box all back in now. Next step is right here where these bevel gears are that power the horizontal power takeoff. We need to seal all those back up. I've taken some time. I've cleaned this. I got it good and washed out with mineral spirits. You know, I want to make sure we got plenty of oil running in here. So I'm going to take a minute here and just lube these up real good before we seal them up. It looks like there's probably some oil that's pumping in from the saddle or the knee over here that's lubricating these, but still I'm going to give them a lube while we're in here. All right. So this block here will now come in just like so, and a bunch of screws holding it together. All right, so now we will put the big drive pulley back on, and it goes in like such. I want to lubricate these gears before I go in there. That should be good. They're going to mesh up on those gears on the back side there. And before I get too deep into this, I need to get this lined up. All right, it goes on there something like that. I had to figure out which bolts go in here, but it's these right here. So there's five bolts that put this on there, and we'll start snugging those up. Before I get too far in this, something's not right. Alright, so that's turning, and that's turning my gear that will drive the rapid traverse. And if I were to turn this inner piece, yep, that's turning my feed. So that's all good. I don't know why that was seizing up. Let's try this again. Huh. What is going on? think it's hitting that bolt back there. That's what it was. It was just hitting, one of these bolts was sticking out too far and it was hitting in the back. But that's turning great. And that one's turning as well. I'm going to tighten these down now. Alright, so we've got the main pulley back on here now. It's turning. And as you can see, when this pulley is turning all the time, it's also turning this drive shaft here, which is the one that powers the Rapid Traverse. Now there's also an inner hub that goes through. Remember, there's another gear back there. And this is what will power the actual spindle as well as the feed when it's engaged. And it's only engaged, of course, when you physically engage the machine. And to do that, there's a little clutch mechanism in here. So we got a little machined off surface here, and a clutch pad fits on that. And basically we're going to transfer it from this gear right here to the clutch, which will then have everything going throughout the machine. So the first step, well actually I've already got it sitting in here, is this gear. We need to bolt this in place. I've got it just kind of sitting up there right now. That's not lined up. So let's get these 6 screws in here tightened in place. All right. Next piece to go on is this inner gear, and again it meshes with the outside there, and there's a clutch lining on both sides of this. That's going to pressure. You got the inside pressure plate here and an outside pressure plate that will compress this in and tighten this up from friction. So this just fits right in there. There we go, just like such. And then we've got the outer pressure plate here, and it needs to go on next. Let me wipe this down. So this clutch has an outer pressure plate here, as you see, and there are little holes in the back here that line up with these springs, and there's 2 pins in here. So we need to make sure this goes on so that all that is properly lined up, and it's just a matter of feeling it and getting those springs and pins to all fit down in those little grooves, just like such. This little spider piece here is going to fit up over a little bell-shaped piece here in a minute, that when you engage it, it's going to basically cause these fingers to move out. And when that happens, it pushes the clutch plate up against this, creates friction between all this, and then drives the inner hub along with the outer hub. It's all keyed together. So you can adjust the tightness of this. There's a little spring-loaded pin in here. And if you remember, there's a little gear machined to the inside of that piece in there, and basically what you can do is you can index this around, tightening it and loosening it into fitting this pin into any one of those pieces, and that allows you to tighten this clutch up in operation. So if you've got one of these mills and you know the clutch is slipping, it's a fairly easy fix. You just come in here and tighten it up. Presto, you're done. So you can fine tune this once you kind of get the machine in place. I'm going to leave it a little bit loose right now because it gives me the ability to get the next piece on, the little bell-shaped piece, and then we'll tighten it up once it's on there. But before we do, there's a little washer that goes here, and then there's a nut that's going to come in here and kind of tighten up against that. You know, this nut doesn't stay tight all the time because you do have a little bit of adjustment in there to tighten this clutch up. But we want to go ahead and snug it up in place where it's at right now. So let's get that going here. With that tightened up, and again, this is basically just to keep this from coming out too far because you still have some adjustment in here. But this little bell piece is what's actually going to tighten up the fingers. And again, I got it a little bit on the loose side right now because I've got to be able to get this on. So I'm going to, there we go. We've got that on there now. And now I'm going to pull the pin out. And we're going to tighten the clutch up. A couple of washers go on here. And then there's this castle nut that has a cotter pin in it to keep it tight. Alright, so let's show you how this works. So again, in normal operation, just the outside wheels turning. Just the one shaft over there is turning. Now I'm going to engage the clutch, which pushes this bell out, tightens the clutch up. Now everything's turning, both the inner and outer shafts are turning, and if you look down here, both the feed and the rapid traverse rods are turning. So this is working. Again, we may have to fine tune this clutch once we get it running, but for now, I need to put a cotter pin in here and put the belt back on, and I think we're ready to test this thing out. Well, we got it up and running, and I've been messing around with this thing for a few minutes, and I thought I'd give you guys an update as to where we are with this repair and whether it's a success, failure, whatever you want to call it. So just to back up and let you know where we were starting from, when I got started on this mill, the rapid traverse clutch was slipping in all three axes. So, you know, my X, my Y, and my Z, up and down. And coming in here and playing with it, you know, on the table, everything looks real good. In and out. Not a problem. But we do have a little bit of problem on the Z-axis, and here we're still getting some slipping. I can tell you guys that I've made a tremendous improvement in the machine, but I'm really not 100% satisfied with it. I was really wanting this Z-axis to work. You know, going down is no problem because we got gravity working in our favor, but coming up, it's just slipping like crazy. So, you know, now I guess, what am I going to do? Well, for now, we're going to just use the mill. Now that I've been into it, and, you know, before I got started, I really wasn't exactly sure what all that grinding noise was, and I was really concerned that I had some gears that were stripping out. Now that I know that it's a slip clutch, that's what it's designed to do, and it's doing what it's designed to do, although not as effectively as it should be. I know I'm really not hurting the mill. I'm not helping it any, but I'm really not hurting it any. And I can know that for lifting up on the Z-axis, you know, you can always go back to the good old-fashioned do it by hand method, and that is probably what I'm going to do for now. I will comment and say that when I was looking at options, at first I was thinking of replacing that part that had the little detents that were worn in it, and I'm still not 100% sure that that may not fix the problem. But I did some inquiring, and I found a company out in California that actually has that particular part, new old stock, sitting on the shelf. Problem, he wants about $600 for it, which is a lot more money than I really want to spend. I think I paid $800 for the whole milling machine, and to sink that much money into one part just makes me cringe. I could make the part. I don't know that that would fix the problem though. Maybe if I could find some heavier springs. The springs that I put in there are, from all I can tell, very comparable to the ones that were original to the machine, but they're not a perfect match. And I've got the strongest ones I could find in that size on the McMaster Car website. So I may need to look and see if maybe I can find even some heavier springs somewhere else. Now that I know how to tear in the machine, it won't take me near as long next time. Another option, the same company out in California that has the replacement part also told me they've got a fixture set up where they can basically rebuild that clutch pack, put new springs in it for me, and get it calibrated to the factory specifications, which I'm not even sure what they were as far as torque. They got a fixture that they can test it on. They want, I think, $450 to do that. Again, more than I really wanted to put into it, but it's an option. So for now, we're just going to use the machine. At some point in time, we may try to see about doing something else to solve this problem. I don't know yet. We'll just have to see. Ultimately, I think I'd really like a bigger milling machine anyway, so I'm not sure I really want to sink a lot more money into this one. So anyway, that's where we are. We're going to call it a partial success, maybe mostly success. I'm definitely better off than where I was, but still not 100% satisfied with what we're working with. So thank you guys for watching. We'll talk to you later.